Alrighty guys, so first we're going to talk about lesson 4.1, and that was about piecewise functions. Basically what a piecewise function is, it's a function, so it starts with f of x is equal to, and then what it is it's multiple, at least two, so two or more functions that each have their own domain. So we write it such like this, and then we'll have function 1. We'll call function 1, let's just say y equals mx plus b. And that is for the points x greater than or equal to some point a. Okay? Then we'll have a second function, right? So y equals, and then we'll say nx plus c, where it's some different function, and that will typically pick up at the same domain, but it doesn't have to be. So we could have something like x is less than a, but we could also have something, maybe x is less than q, right? So we have all that, and then what we do is we just graph these functions using this domain only. So, for an example, I'd have something like f of x is equal to the piecewise function such that, what do I have here? I have x squared minus 1 for x greater than or equal to 1. And then I have 2x minus 1 for x less than 1, right? So then I gotta graph these. So I got my graph here. And what I do is I make an XY table for each, right? But we're in Algebra 2, so it's no longer an X table, it's an F of X table, right? So we have F of X, we're going to do F of, I'll just go ahead and write in right away x squared minus 1. So now you ask yourself, where do I start? Well, I start at my domain restriction. So I have x greater than 1, so I put in 1, because x is an independent variable. It can be anything I want, right? From there, I follow my domain restriction. I have x is greater than or equal to 1. So then I just pick numbers greater than 1, right? So I'm going to go 2, 3, 4. Right? I plug in 1. 1 squared is 1, minus 1, 0. Plug in 2. 2 squared minus 1. 2 squared is 4, minus 1, 3. 3 squared, 9, minus 1, 8, 15. So on and so forth. So then I graph this. Right? I come over to my graph using my XY table. And I go to where I start. So I start at my domain restriction, which I said is at 1, 0. So that's right here. Then I have to ask myself, is 1 in my domain? So I look, x is greater than or equal to 1. So yes, it is in my domain, so I use a closed circle. I then plot my next point, 2, 3, 3, 4, 5, 6, 7, 8, so on and so forth. Then I just graph that curve, right? I then make another table. 2x minus 1, okay? Again, I start at my domain restriction, so I start at 1. But then, now x is less than 1, so I'm going to plug in numbers less than 1. So I got 0, negative 1, negative 2. So I plug in 1. 1 times 2, 2, minus 1, 1. 2 times 0, 0, minus 1, negative 1. Negative 1 times 2, negative 2, minus 1, negative 3, negative 5. Okay? Again, I go to my chart, or my graph, I go to my first point, 1, 1. But this time, it is x strictly less than 1. So I put a open circle. Then follow that. I have this nice straight line, like that. This would then be my final answer, but then I have to state my domain and my range, right? So my domain, my range. So I ask myself, what values can I plug in for x? In this case, I can plug in every single value for x and I'll get an answer. So my domain is all real numbers. Then I go, what is my range, right? Well, we see how these overlap and they go in opposite directions. That means if I were to take these two graphs and squish them up against the y-axis, I would have them squished everywhere, right? So my range is also all real numbers. And that's the basics of piecewise functions. So hopefully this video helped on the 4.0.